Hi everyone, and welcome to yet another video on my physics theory that I coined the velocity horizon theory. This is probably the only video that you have to watch if you're a physicist, but it's also very fun to watch the other old videos, especially the previous one. It contains several thought experiments that can make the concept a little more clear, but on the other hand also doesn't have a clear line between what is a thought experiment and what is actual theory. In this video I'm going to give you a short summary of my theory and all the key takeaways. Also, I'm going to tell you about the physics experiments that actually are a very good way in which my theory shows to have a value. So let's get started. Velocity horizon theory is a theory I came up with after thinking about how we could derive E is mc squared as a formula from looking just at energy, mass and time. After that, I figured out I wanted to go beyond that and was starting to do thought experiments. This is over a decade ago that I was doing that, and even as a child I was thinking about how these things worked. So when you see an interaction with a photon at its maximum speed, the speed of light, it doesn't mean that anyone with a different velocity is looking at the same photon. What I'm saying is that the speed of light is a horizon of the maximum speed. It's like the distance from me up to the horizon that I can look at, but the horizon is different for everyone at any given moment, but it's always just as far away. Imagine you're on a spaceship flying away from Earth with 1,000 meters a second, and your loved one is still on Earth, and he's thinking, wow, she's flying away with 1,000 meters a second. But likewise, you think that your loved one is going away from you with 1,000 meters a second. Now, you might encounter an asteroid going 1,000 meters a second away from you in the same direction as you are. And your loved one on Earth is not actually seeing that asteroid going 2,000 meters a second because velocities do not add up. This, however, doesn't make the fact that you perceive both Earth moving away from you 1,000 meters a second and the asteroid moving away 1,000 meters a second less true. This is how I know that there must be a velocity horizon. So it's not the speed of the photon that is absolute. It's not. It's relative. But the maximum speed that we can interact with is a given. Anything that goes faster is something we cannot interact with, and if it's something that we cannot interact with, it is going infinitely fast. Mass is going infinitely slow. If there's only mass, it doesn't ever change, and it's infinitely slow. You need a lot of energy to get movement, and the more energy you add, the faster things will be going and the faster time will go. And if you have something that is energy, then it goes infinitely fast. Now you say, well, it does not, because there's the speed of light and this is pure energy. The thing is that what we consider to be mass, like ourselves, contains a core of energy. It has the nature of energy. And every bit of energy has the nature of mass, and hence we can interact. But anything that is just mass and nothing but mass, and anything that's energy, nothing but energy, those are two polar opposites, both, and one is going infinitely slow and one is infinitely fast. And this is never so, but it's always so. And all that happens is between these two, but it doesn't mean that there's nothing beyond what we can interact with, because there is, because anything that that is moving has a speed different from ours, because we as an observer are always standing still, and everything that is moving is going faster than us, and in that way has the velocity horizon at a different, further point. Now there's also, on the other hand, things that we can interact with that something with a different velocity can't interact with. So it works both ways. If you have, so if you're standing over here on the curve and someone else is over here because it's going faster than you are, then it can interact with things over here while you can't, but you can interact with things on the other side that the other one can't. So there are always things that for you are going infinitely fast that are not going infinitely fast for everything around you that is moving, and they can interact with it. But there's always things that are going faster that can interact with things that they cannot interact with, and so forth. So this is like this daisy chain of interaction horizons. You could theorize that this could go on forever. However, it is always a paradox. Yes, there's always something that can go faster than the previous object, which for the observer is zero, and you can add velocity to it. But you can never add them all up, because it doesn't really allow to be added up, because there's this thing called space-time, and it curves. So both are true at the same time. I hope that everything is clear up to this point. If not, then I suggest you watch my other videos. Knowing that there is a velocity horizon opens up the concept of infinite speed, which is to things with that have a different velocity, not infinite speed, if it is within their velocity horizon. Also, it can explain why some things appear to be random. There is an experiment called the mirror experiment, where if you move a mirror in space very fast, new photons will appear, they will pop into existence. Now, they were there before, but they were beyond your velocity horizon. And if you're zero and someone is going pretty fast, but the mirror is even going a lot faster, then it has the ability to make things that are way beyond your velocity horizon to enter into what you can interact with, because it slows it down if it bumps into it, and then it comes within your field of interaction. The second experiment that it has consequences for is the double-slit experiment, where you see probability coming in. There is absolutely no probability. There's always this perfect configuration that you can't deviate from. And if it seems random, it is because these photons are actually interacting with things beyond your interaction field. and you can only see that effect the moment that you're able to interact with it. As difficult as it may seem to understand, it does make a lot of sense, because for us things are actually going infinitely fast, as long as it's not in our interaction field, but things that are going infinitely fast are actually interacting with things beyond our interaction field that can have a different velocity from the thing that is out of sight of our interaction field. So it interacts with things that we do not know of, and then comes within our interaction field, and it appears as if this was something random. The last experiment is the EPR experiment. This is about quantum entanglement, things that appear to happen instantaneously. Yes, it is possible, because things that are outside of our interaction field don't experience, they happen instantaneously because they do not experience what we feel is distance, is not distance to them, because it's not there at all. Because when there's no time, there's no mass, there's no distance. And the experience from something that is happening instantaneous is the exact opposite. That we are the ones that are happening instantaneously, because we're on the other side. There's nothing different about energy and mass. They're just each other's polar opposite. From the perspective of mass, there is energy, and from the perspective of energy, it's mass, and mass is the energy. So they do not experience the distance that we are experiencing, because there is no time between one place to another, because it's outside of our velocity horizon. If you want to know more about the experiments that I mentioned, I will post the links in the description below. As I mentioned in my previous video, it remains speculation if something that is going really fast is actually going towards us. And if it goes even faster, it's actually going towards us slowly. It doesn't seem like there is any other way that it could be. But it's definitely something that I would have to think about a little bit more, and I'll come back to you if I gain insight on this. Thank you for watching. Let me know what you think about this video in the comments below, and please like and subscribe my video. Thank you, and I'll see you later.